Alright, this is Shen, and it's gonna be the video for Lab 2. And Lab 2 we will talk about the tools in Sketch, okay? And we'll talk something about the revolving, revolving, and also the our project parts. Okay, one of the simple parts. Then in the Sketch we will talk about the constraints and the reference, um, measuring. Not so much. We'll talk about the trimming and how to move the sketch. Okay, so I recommend you to read something about the under constraint, fully constrained, and over constraint. This typo should be constrained. Okay, so in mechanical drawing, there's those concepts are in the mechanical drawing area. So let's go ahead and um, a fully constrained sketch in NX will show different colors. Okay, and as to this concept about those three uh, constrained conditions, you have to learn that yourself, or you should have the basic knowledge about this. Okay, so let's have a look at what um, those situation will be. Okay, and I have a sketch here with two identical geometries, and the one is fully constrained and the other one is under constraint. That's if you remember, you can double click and get into the sketch. Okay, so here we have, uh, as you can see, we have dimensions already. So those dimensions will constrain the geometry, as well as those. You can see those icons here. That's geometric constraints. So both dimension and geometric constraints will define the shape of your geometry. On the other hand, the bottom shape does not have the dimension. And how do you tell if this is fully constrained or not? Okay, two methods. You can use the invert dimension tool, or you can use the geometric constraint tool. Okay, if you click this command, you can see the color change. Okay, so if it's green, that means this is fully constrained, and you can see the bottom geometry does not change color, and also there are those small arrows. That is the degree of freedom. So, for example, just use this as example. You can see the 2 points has for each point it has 2 degree of freedom, x and y. So if you try to move this, okay, you will be able to move this line. You can move x and you can move y. Okay, I'm holding down the left mouse button and drag this line. So what if we constrain the x direction of the degree of freedom? So we can give this a dimension like so. So as you can see, the arrow on the x direction disappeared, but the y direction is still there. So that means this point can move along y direction, but not x direction. Okay, so that's how those little arrows telling you the degree of freedom. And now if you drag, okay, you can drag on the y direction, but you cannot move this point on the x direction. Alright, that's pretty simple. And over constraint, I don't have the geometry because it's pretty easy. So we can give this line another dimension, and there's already one there. Okay, it will say there's error and there's over constraint. So here you can see those dimensions are red, and those geometric constraints. So that means they're conflict with each other. So either you delete one of them, then you'll be fine. So let's delete one of this. Should be able to delete that one, but just go back. Okay. Anyway, so the advantage of fully constrained or versus the disadvantage of under constraint. It's very simple. If you try to move this, you can hold your left mouse button. Okay, it will not move. And if you try to move the under constraint, see the shape flies all away, and the shape does not stay on the same. So that's the disadvantage of under constraint. But again, in this course, we're not crazy about the fully constrained, because it does take some time to finish that constraint. Okay, so here is your degree of freedom arrows. Okay. So now if we have this geometry, how do we constrain this, or how do we make this thing fully constrained, and how do we add the geometric constraints? So the command is here, okay, down to the bottom, and once you open this command, you can see some constraints, and you should be able to see the name if you hover your mouse on the icons, or you can expand the setting tab here, and you can see all the names, and you can actually add some other constraints. And you should be able to know, or you should remember, there's something called those constraints. Okay, they're very commonly used, and it's also in the common sense that you should know them, and they will appear in the exam. Okay. So here, for this particular sketch, the degree of freedom mainly comes from lack of the dimensions. So, but we can also add constraints. Let's say if I want to fix this circle, okay, fix the position. And by the way, this constraint is not on the top by default. You have to check, okay, enable this constraint. So let's use fit. You can pick this arc. Okay. All right. So now you can see the little dot. The center of this arc is green. That means the position of this circle is fixed. But why the circle itself is not green? Because there's no dimensions. So once if you put the radius, okay, now you can see the color changed. All right. And if you put dimension on this circle, it's not changing because the center of this circle is still movable. So that's how you judge if it's fully constrained or under constraint. All right, and yeah, some people will feel annoyed, or sometimes it's necessary to hide those constraints because you're doing some other work. So here's the option: you can turn off the display of those constraints. If you click once, the constraint will be gone, and they're hidden but they're not deleted. Okay. So you can display them again. And how do we delete constraints. So let's see, if I have a rectangle here, and with those constraints, okay, the shape should be defined. So this bottom line will be horizontal because you have the perpendicular and horizontal here. If I put another horizontal on this line, okay, alright, same still works. Okay, I'm trying to put this thing over constraint, maybe make them two equal. Well, that's very hard. Okay, and that will be over constraint. Alright, now you see the red dimension and the red constraint icons. So how do we fix this? You can either delete the dimension or you can delete the constraint. So there's a show or remove remove constraint. That'll be here. Okay. So use this command. You can see all the constraints in this sketch, and you can also see which constraint you have on the selected object. Okay. So you can see there's the names of the lines and what constraint it has. And there's also in this container, in this bracket, you can see it says over constraint. So if you delete this, okay, remove highlighted, it should give you kill that over constraint. So that's how you delete a constraint, or you can investigate which constraint is on this object. Or the other way to delete the constraint is you can hover, try to pick the constraint. Okay. Now that's the quick pick menu. Alright, this is hard to pick, and maybe this. Yeah, sometimes you can pick the constraint from the sketch just by click on the icons. I guess it's not workable here. Alright, that's why. I have the filter set to curve. Okay. Alright, so you see the text says perpendicular constraint. You can click that. You can either use this shortcut menu or you can just press delete. Okay. So that's a faster way to delete your constraints, but you have to know which one you're picking. See, we have two constraints here. Okay, the coincident and the perpendicular. Alright, let's come down to the reference and active curves or dimensions. So I believe if you have used the Pro E, you can actually draw reference lines. But in NX, so something like this, okay, it will be much convenient if I have this reference line first, then I draw the two circles, okay, on the end point of this line. So let's say we have a circle in the middle, and I want the two circles to be 120 on each side. No, I'm sorry, 60 on each side. So we can draw a line first, okay, and make this to the middle. How do we do that? We can use constraint. Okay. We can use this what do you call this, midpoint. Okay, first we pick the point or the line. We can pick the line. Then we pick the midpoint. That will be the center of this circle. Okay. To pick the center of the circle, you can hover on the circle itself, or you can get into the center point. Okay, now you see this this line is centered to the circle, so we can put a dimension here, make this 120. All right, and then we can draw two circles. Okay, so these two circles are centered at the center of this circle. Okay, and after this, we don't need this line, or you want to keep this line, you can turn this to a reference. You can either use this shortcut menu, and you can use this command to convert to reference. Okay, you can also use the traditional way, convert to or from reference. It's deeper down in the menu. Okay, you can pick the object and let's say apply. Well, you can convert to active, apply. So what's the difference? The difference here is when you finish your sketch, okay, when you try to do the extrude, let's say, let's use single curve, so you know we can pick the active curves. Okay, we can use them to generate a 3D solid, but we cannot pick the reference. And that's the good thing about reference, is you can have a lot of reference to define the position of your active curves, but they will not interfere with your 3D features. So that's how you convert or create the reference curve. Okay. So here also you can convert a dimension to reference. So that dimension does not have any control over the line, the curve. It only shows the length of the curve. So that will reduce a lot of problem of the over constraint. Okay, now let's go back to the sketch, and for some geometry like this, you will definitely need the quick trim command. So it will save you tons of time. And the quick trim is here beside the quick extend command. So these two are very commonly used in AutoCAD or Pro E. So I'm sure you're familiar with this. We can try the quick trim command. You don't need to define the boundary curve. It will smart select whatever you hover on the geometry. So let's say I want to cut the straight line in the inside of the circle. You can just click the line, and we can cut the top half of the circle, just like that. Okay, unless you have very complex geometry, you have to define the boundary, and you have to define the curve to trim. Usually, all you need is just click on the curve you want to delete. Okay, so that's the way you use this trimming command. And also the quick extend command, you don't need to define the boundary curve again. Just hover on the curve, and for straight line, the left and the right side, they're different. Okay, so you can extend this way, or you can extend to the right. And for the arc, you will go around until it hits the next object. Okay, so that's how you use these two tools. This is particularly neat when you have something like, okay, I have this is a little bit shorter than what I want, and you don't want to delete this and draw another line. That will be too much work. So you can use extend, then we can cut this off, use quick trim command. Okay, so that's very convenient. again, sketch does matter a lot during this modeling process, and you want good quality sketch, so you always want to use those tools to help you. Okay. Alright, so what's next? Yeah, so a lot of people are asking how to move this thing, move a curve. Okay, the best way is simply just drag the curve. So you can pick this curve, hold your left mouse button, and you can move this. And how the geometry change, that depends on the constraint or the degree of freedom this thing has. So for example, this fully constrained geometry, no matter how you drag it, it will not move. Okay, and let's see what's constrained. Okay, for example, for this geometry, if you drag this, okay, the circles, okay, they're not constrained, so they will go all the unexpected shape. So that's another advantage of the fully constrained geometry. And if you want to use a command that's Ctrl+T, or I think it's here, edit, move object. So you can first select an object. So we can select 4 curves, and this is the moving coordinate system. So you have the option to move X and Y. You can also rotate. Okay. So when you're done, you can press the middle mouse button. Okay. Now that's the 2 ways to move object. Then hide and show. So we have a lot of mess here. Okay. We want to hide something, and without delete them, you can pick this up. Okay. Right click, and seems it's not here. So it will be here. This menu bar you can hide, or Ctrl+B. You can hide that geometry, and if you want to show something, you can use show, then pick things up. Pick what you want to show up. Okay, and also you can hide the features in the part navigator. You can right click, hide the datum coordinate system. You can also hide all the features you want. Okay, so by the way, if you want to hide something, you don't clear the checkbox. That means you're basically deleting the feature. Okay, it's different from hide stuff. So if you uncheck, technically that's called a suppress. It will kill this feature. And if you have a extrude based on this sketch, okay, for example, if we have this extrude here, I can hide the sketch, no problem. And if I uncheck this box, you see the extrude is gone too, because you just deleted the sketch. The only difference is you can get that back. Okay. So you can use the hide command to make your working environment a lot clearer, a lot neater. Okay. Now the next command we're gonna use, beside extrude, we can use revolve to create 3D features. So let me just delete this extrude first and show the sketch. Okay, and go back to the sketch. Alright, so this is pretty complicated shape. Okay, we can get some random shape as we like. and you want this to be aligned. So you can also, to be clear, you can put a reference line here. So remember how to turn this into a reference. Click. You can click. There's a shortcut menu, or you can right click. There's your shortcut menu. You convert to reference. So we will rotate this geometry with respect to this line. Okay. So let's finish Sketch first. So I am out of Sketch, and I'm gonna use Revolve command. Here's the dialog box. We have some options here. First, we want to select the curve you want to revolve. So note that the infer curves here. So once you pick, you will pick everything on that sketch. We want to pick the connected curve. Okay, so we have this curve here. And the next thing is you want to specify your axis. So either you can pick specify your vector, like so. Okay, or you can actually use a 2-point to pick your vector. So it's not necessarily you have to have that reference line there. Okay, let's do a fit first to fix this display problem. We can use this 2-point option to define the vector from this point to that point. Okay, and also we have some options here. We can, it's like extrude. You have the start to end. You can do 180. You can also do 630. Okay, and let's do 630. And click apply. Oh, okay, so that will give you the revolve. Okay, this is pretty easy, and that's a little bit different from the mirror curve. In mirror curve, you have to have a center line, and here in the revolve command, okay, the axis you don't need a center line, or you don't need a line for the vector. You can just pick 2 points to define the vector. All right. So that's the steps to make the revolve, and we have similar exercise. So different from the first lab. So here you actually need to constrain the geometry to make this thing fully constrained. Then that's the steps. Okay. So for the second exercise, you probably need to use the quick trim menu, the quick trim command to trim off this circle, and probably will have a circle here. So, but in the description, it uses profile tool. You can use whatever you want to use to make this geometry. Then for homework, we have 4 homeworks. From homework 1, okay, it's a revolve. Then homework 2 is basically an exercise of the quick trim command. So here you can draw 3 circles first, then connect them. Okay. Then this one is pretty much quick trim again. Or you can use mirror curve. Okay. So that's your quick trim for this circle. Then we have the project coming on. For this week, we will make one small, simple extrude piece. So I have to emphasize on the project goals. The dimension is not required. Okay, the purpose is to successfully assemble the parts together. So if you make this thing 100-inch, okay, make sure your handles are 100-inch separated. So just get the assembly successfully put together, okay. And you don't want, say, if you put this piece really big and you have your handle really small, that's unacceptable. You need to make your assembly look like the real thing. So the model must match the cutter in real life. Okay, we can ignore some details like those manufacturer stamps here. And you're not limited on the method we show you. You can use your own method because this is a kind of complex shape. Okay, maybe our method is not the best. You can use your own way, or you can be creative. It's encouraged that you can use your own method. So for part 2 of the video, I'm gonna do a one of the homework, or one of the homework. I will show you how to do this in a faster way. Then I'm gonna show you how to create this complicated sketch. Okay, you don't have to follow this sketch. Okay, if you have to follow it, it's kind of messy, and it will be a pain to create exactly the same thing. So as long as you get the shape. Okay. Alright, so see you in part 2.